Now, let's look at the inner and outer product of unit vectors. Okay, that's quite straightforward. By looking at the definition, you should immediately get this relationship. I dot I should give you what, right? You see that with the definition. A dot B equals to A multiplied by B multiplied by, okay, here let me not put dots because this is just a algebraic multiplication. So, okay, n into vector. And I cap dot I cap. What is the magnitude of I cap? 1, okay? So it's 1 multiplied by 1 multiplied by cosine, in this case, what's that? 0. Cosine 0 degrees. So of course, this is what? It's always what? I dot I. Similarly, j dot j equals to 1. K dot k equals to 1. So if a unit vector dot itself, it gives you 1. Okay. And if a two different unit vector dot with each other, you will always get 0. Why? Simply speaking, what's the reason? Okay, we said if two vectors perpendicular to each other, the dot product always 0. Okay, cosine 90 degree equals to 0. And of course, all these unit vector, okay, along x direction, z direction, y direction, z direction, they are perpendicular to each other. So any two different unit vector dot with each other, you will get 0. And now for the cross product, okay, I cross I, j cross j, k cross k will give you 0 because they are parallel with each other, right? I parallel with I, and we know that once two vectors parallel with each other, the cross product will be 0. And here, this is if you have a cross product between different unit vectors. It's a little bit complicated, but again, with the right-hand rule, you can determine. First, all the magnitude should be 1, right? We can check this one. I cross j. Okay, by definition, the magnitude should be I magnitude multiplied, which is what, right? Unit vector. Magnitude always multiplied by unit 1, okay? Multiplied by sine 90 degrees, right? Which is 1. So this, the magnitude is 1. And the direction, you can determine if you put first I and then you put j, so it should be k. So the in k direction with length of 1, so that's a unit vector k. Okay. Similarly, with the same thing, you can check that. I hope you can check all the other things with your right hand. If they get the correct direction, some of them will be negative. Okay. So this is a good exercise for the right hand rule. I can tell you it's very important. Later, when you study unit physics 2, the magnetic force is actually given by the right hand rule, the cross product. Okay, and if you cannot determine the right direction of magnetic force, of course, you cannot understand this phenomenon. So this is important. Now, the reason I want to introduce this product of unit vector is that with these things, it's very easy to calculate all the inner product and outer product in standard vector form. Okay, so we have these equations. So we try to understand how we get this equation. Okay, we can check the first one, A plus B. If A can be written as ax I cap plus bx, ay j cap plus az k cap. And b can be written as bx I cap and by j cap plus bz k cap. Let's try to evaluate a dot b. Okay, so the good thing here is that once you write it in the standard vector form, you can always use those standard manipulation in the algebraic. There's algebraic manipulation. So you write this way. Dot, okay. Okay, and then if you multiply them out, then you should be this multiplied by this multiplied by this multiplied by this, right? So you are totally you're going to get 3 by 3, 9 terms. So you get ax I cap dot bx I cap plus ay j cap dot by bx I cap plus az k cap dot bx I cap, and then the 3 term multiplied by this, so you get ax I cap dot by j cap plus y j cap dot by j cap plus a z k cap dot by j cap plus this 3 multiplied by this one, so ax I cap dot bz k cap plus ay j cap dot bz k cap plus az k cap dot bz k cap. Okay, I write them in 3 different lines, so it's easier to track them. Okay, because that's 3 by 3. And then you can see here this. Now in this problem, those ax, ay, bx, by, they are just some number in front of them. So what you have to pay attention to is those unit vector, right? So you can see that the only non-zero term will be this, and this, where you have I dot I, j dot j, k dot k, right? All other will be 0. If you have 2 different vectors that with each other, so j dot I will be 0, k dot I will be 0, so this will be 0, this will be 0, 0, 0. Okay. So only the 3 diagonal terms survived. And I dot I will give you 1. So this is ax multiplied by bx. This is ay multiplied by by. This is az multiplied by bz. Okay. And it will give you a very symmetric and simple form. So a component multiplied by b component. X component multiplied by x component, y component multiplied by y component, z component multiplied by z component, and add them together. So that will give you the inner product. Okay. Similarly, if you do these things, you can prove this equation. Okay. Now here you have 1, 2, 3, 4, 5, 6 terms, because if you go back to look at our rule, you have 3 zero terms and 6 non-zero terms for the cross product. Okay. In fact, when you do that, you get something there. But all the 3 diagonal terms will be 0, and the 6 non-diagonal term, off-diagonal term, will give you something like that. So finally, you can check, you get this. So I'm not going to repeat this calculation. Okay, it's straightforward. It just take a little bit time. But for this, there is a simple way to write down that. I don't know if you have learned that. If you write this way, I cap, J cap, if you have, okay, A cross B, you can write it this way. It will be I cap, K cap, J cap, K cap, and you put AX here, BX here, oh no, AY here, AZ here, BX here, BY here, and BZ here. And there's some way to extend it. Have you learned this before? Yes. Okay, so in fact, I don't remember this clearly. I guess this is first. You put I here, right? And you cross this, loop this. And it should be this diagonal subtract another diagonal, right? So A, Y, B, Z subtract A, Z, B, Y. And then you have, okay, this one will be negative J. And you cross this, so you have this, you get AX minus BZ of A multiplied by BZ minus AZ BX. And this one is plus K cap, and you cross this, so you get this square, so you get AX BY minus AY BX. You can check it should be the same as that one. Rearrange it. And if you don't familiar with that, you can go back to check your math textbook. Okay. Please note that all these procedures are important. I do require you know this procedure. Okay. I think you already have some feeling for the last test. I do require you to do integral and derivative and master the vector manipulation, those things. Okay. So, any question here? There are the vectors we need to know. Okay. Next thing, we are going to use these things to start the physics.